So, hello everybody. Today in my second video I would like to talk to you about allegations method. Allegations method is one of the most important topics in pharmaceutical calculation. With the help of this method you can solve very difficult pharmaceutical questions when we are talking about the mixture of two to more preparations. Let's say the alligation method is divided into two forms: medial, alligation medial, and alligation alternate. What I try to do today in this lecture, I give you examples, I will write down examples, and we will solve these examples together using these two different methods. So in this case, you can understand it better, okay? Let's say, what is the definition of alligation medial? We use alligation medial when we want to calculate the final strength percentage of a preparation, of a mixture of preparations that we use. Let's say you have to mix 3 to 4 different ointments, same ointment with different strength, and the question is, what is the final strength of the product? So in this case, to calculate the final strength of a preparation, we use alligation medial. But what I mean, I give you an example. Let's say the question is, question 1, what is the percentage of zinc oxide? What is the percentage of zinc oxide prepared by mixing three different zinc oxide ointment. Ointment 1, let's say 200 gram of 10% zinc oxide. Ointment 2, let's say 50 gram of 20% zinc oxide. And the third ointment is 100 gram of 5% zinc oxide. So, what is the percentage of zinc oxide prepared by mixing these three different ointments? Means, what would the final percentage strength of our product if we mix three different ointments together? In what percent we get the product? The product that we mix it together, what percentage does it have? So, to solve these problems, you have to use the alligation medial. So the first step of alligation medial, you have to determine what is the amount in gram of active ingredients present in each ointment. Let's say, we say 10% zinc oxide means in 100 gram, because percent means part in 100. So in 10% means in 100 gram of zinc oxide preparation, there is 10 gram of zinc oxide. How much is in 200 gram? So 2 times. So we do this time. 10%. So 10 divided by 100 is 0.10. Multiplied by 200 gram. So the answer would be 20 gram. It means in 200 gram of 10% zinc oxide, there is 20 gram of zinc oxide. 20 gram of zinc oxide. The second one, we have to do the calculation again. 20% means 20 divided by 100 is 0.20 multiplied by 50. So, how much is in 50 gram of 20% zinc oxide? If you do the calculation, the answer would be half, 10 gram of zinc oxide. So, in 50 gram of 20% zinc oxide, there is 10 gram of active ingredients zinc oxide. And the third one would be 100 gram of 5% zinc oxide. 5% zinc oxide means 5 gram of active ingredients, which is in this case zinc oxide in 100 gram. So how much is in 100 gram? The same amount. So 5%, 5 divided by 100 multiplied by 100, the answer would be 5 grams of zinc oxide. So the second step, we simply have to sum it up. How? We do this preparation that we prepared, how many grams of zinc oxide present in this preparation? Let's say 20 grams plus 10 plus 35 grams. So these mixture contain together 35 grams of zinc oxide. Zinc oxide. So, and what we prepared? We did a preparation by mixing 200 grams, 50 grams, and 100 grams. So if we mix all together, the final value would be 200 plus 50 plus 100. So we prepared 350 grams of ointment. In this 350 gram ointment, there is 35 grams of zinc oxide. So if you want to do the percentage strength, we do simply 35 grams is in 350 multiplied by 100, because we want to know what is the final value in percent. So 35 divided by 350 multiplied by 100. The final value would be, a strength value would be 10%. 10% what? Is it 10% gram in liter? Is it milligram in milliliter? Is it gram in gram? What is it? The value, the unit is very important. We calculate the amount of gram in gram. So the 10% weight over weight is. The answer would be 10%. Okay? Let's go to the second question using alligation method to calculate the problem. So, if you note it, so I'm going to clean the board. So, I try to do it as clean as possible so we have no problem. So, let's go to the second questions. So, second question. So, what is the percentage strength of alcohol? What is percentage strength of alcohol in a mixture of 500 milliliter, 40% V per V, and 400 milliliter of 21% alcohol. 400 milliliter of 21% alcohol. So 400 milliliter, 500 milliliter, and a sufficient quantity of non-alcohol third solution. So we use a third solution, non-alcoholic, possibly water, to make a total of 1000 milliliter. So the question says, what is the percentage strength of alcohol? So we do two different mixture. In one bottle we have 500 milliliter of 40% ethanol. In second bottle we have 400 milliliter of 21% ethanol. We mix them together inside the big bottle and we add a non-alcoholic solution to get to 1000 milliliter, 1 liter. Means when we have 500 milliliter 40% alcohol, we have 400 milliliter of 21% alcohol. it would be 900 milliliter. We have to add another 100 milliliter non-alcoholic solution to reach to 1000 milliliter. So the question is, the second two is the same as the first questions. So you have to calculate how many milliliter, see, we are talking about alcohol. How many milliliter of alcohol is present in 500 milliliter of the first solution, and how many alcohol is present in this 400 milliliter of the second solution. Let's say, again, 40% means 40 milliliter alcohol in 100 milliliter. How much is in 500? We do 40, 0.40 multiplied by 500. So the value would be, simply, I do not need the calculation, but it's better, anyway, it's better. I mentioned always, you always use calculators to calculate, because later on there are some very difficult pharmaceutical questions, pharmaceutical calculation. You have to use like 2 to 3 pages to reach the final answer. So always use pharmaceutical calculation. So 0.40 multiplied by 500 would be 200 milliliters. So the first solution contained 200 milliliter alcohol. The second solution, let's say 21% means 21 gram or milliliter alcohol in 100 milliliter, 100 gram. How much is in 400? So simply 21% means 0.21 multiplied by 400. 0.21 multiplied by 400, you get 84 milliliter. 84 milliliter alcohol. Okay? And here is a trick. If we have this type of questions, if we add a non-alcoholic solution like water, something non-alcoholic as a diluent or as a vehicle, the percentage strength of our non-alcoholic solution is 0. Means here is 21%, here is 40%, this is no alcohols inside, so the percentage would be 0. How many milliliter do we have to add from this non-alcoholic solution? As I mentioned it, we need to reach to 1000 milliliter. Here we have 500 milliliter, here we have 400 milliliter, so we need another 100. So the answer, so 100, let's say milliliter. If you don't mix it, milliliter. It's better if you put unit. Sometimes I forget it, but always try to put the unit. So again, alligation media, we want to calculate the final strength of the product. So again, we have to sum them up. How many milliliter of alcohol is it in this preparation? 200 plus 84 plus 0 is 284 milliliter alcohol. Okay? And what is the final volume of the preparation? The final volume is 500 plus 400 plus 100 is 1000 milliliter. Again, to calculate the percentage, what you have to do, 284, again divided by 1000. So 1000 on 1 liter solution contain 284 milliliter ethanol or propanol or whatever, and divided by 1000 milliliter. We need the answer should be in what is the percent strength. So we have to multiply it by 100 at the end. So the answer would be, so 200, always use calculator. As I said, you can do it possibly without using calculator, but use the calculator. Divided by 1000, multiplied by 100, the answer is 28.4%. 28.4%. So, this is the final concentration of this preparation. Let's go, maybe I can give you another example from that we can use alligation media to solve our problems, and after that I will jump to the alligation alternate. Okay, so again I try to clean the board. I use ethanol to clean the board, so there you go. Clean. So I give you another example. So let's do this. Let's do the third example. So question 3. So the example that I give you in this lecture, you can find definitely similar question in your exam. You just have to know where and when to use this calculation. The first question would be, there is a pharmacist who wishes to consolidate batches of ginkgo biloba leaves. So we have some ginkgo biloba leaves. Ginkgo biloba. The first batch contain. So the pharmacists want to put these 2 to 3 batches together, and the final answer would be what is the percentage of the active ingredients inside. We can see. So in the first one, it says 200 gram. So 200 leaves of ginkgo biloba containing 22% weight per weight glycoside. So one of the main active ingredients of ginkgo biloba is glycosides. So the second batch contains 150 gram of 26% weight per weight glycoside. So the second batch contains this amount of ginkgo biloba, and the third batch, we also have the third batch. The third batch contains 80 gram of, let's say, 80 gram of leaves contain 27% weight per weight glycosides. And the answer would be, what is the percentage glycosides? What is the percentage glycoside at the end product? So a pharmacist has 3 batches of ginkgo biloba leaves. The first batch contained 200 gram of 22% glycosides. The second batch contained 100 gram, in which 26% active ingredients and glycosides. And the third batch contained 80 gram of leaves with 27% glycosides. So the answer, the question is, what is the final percentage? Again, you have to calculate how many gram, you are talking about gram per gram, how many gram of glycoside is in 200 gram, 150 gram, and 80 gram batches. So the first product would be 21%, means 22 divided by 100 is 22, multiplied by 200 gram. This one. You also can use the ratio proportions. You can watch my video number 1. It's a basic or fundamentals in pharmaceutical calculation. Here you also can do it with ratio and proportion. Means 22% means 22 gram is in 100 gram ginkgo biloba leaves. What about in 200 gram? So we need x is equal to 200 multiplied by 22 divided by 100. So this one is the same as this one. So we say 0.22 multiplied by 200. So this batch contains 44 gram glycosides. Again, use calculators. It's very important, because a simple mistake you get the false answer. The second batch, let's say 26% means 0.26 multiplied by 150. So I do it here, you also can do it like the same, 0.22. 26% means 26 gram in 100 gram, the same as this one. What about in 150 gram? You can calculate the x. So 0.26 multiplied by 150, the answer would be 39 gram glycosides. And the third one, 80 gram, batches of 80 gram of 24, so say 27% is 27 gram glycoside. Main active ingredient is 100 gram. How much is in 80 grams? So 0.27 multiplied by 80, 0.27 multiplied by 80, the answer is 21.6 gram glycosides. Okay, so what is the final percentage? Again, you have a bag, the pharmacist mix all of them together, and you get a handful of leaves, and you want to see what is the percentage of glycoside here. Again, you have to see this bag contain how many gram of glycosides, so this value should be sum. So 44 plus 39 plus 21.6. The answer would be 104.6 gram. And what is the amount of leaves in this bag? 200 gram plus 150 plus 80. Use calculators. 200 gram plus 150 plus 80. 430 gram. So we would say there is 104.6 gram of glycoside in our bag, which weighs 430 gram. What is the percentage of the final product? Multiply. When we are talking about percentage, means part in 100. So answer would be 104.6 divided by 430 multiplied by 100. The final percentage would be 24.32% weight per weight. This is the answer. Okay? So these are three main questions that you get from alligation. You can use alligation method to solve the problems. In a few minutes, I get into problems requiring use of alligation alternate to solve them. These alligation alternate are very, very important because if you are a pharmacist, you are working in a pharmacy, you have to use this method on a daily basis. So I will clean the board. And if we start with alligation alternate. So I try to clean it as good as possible. Don't mind the board, as long as you can read and you can learn it, that would be fine. So let's go. So we do yet now alligation alternate. As I said, it's a very important subject when we use alligation alternate is a method that we use when we have 2 to 3 to more mixtures. We mix them together and we want to get our desired percentage. So let's say we have 3 to 4 different alcohols, 10%, 20%, 70%, and 90%. We want to mix them together in order to get an alcohol with a concentration of, let's say, 13%. Alligation alternate gives us these proportions. The proportions that this mixture should be mixed together in which we get our desired concentration. So I give you an example. And using this example, I use alligation alternate to solve it, and now you learn it. You will learn it. Let's say, in what proportion, question is, in what proportion should alcohols 95% and 50% to be mixed to give 70% alcohol? Beautiful question. Bad handwriting, I know it, but as I said, as long as you can read it, so no worry. In what proportion should alcohols 95% and 50%? So we have a bottle, we have a beaker of 95% ethanol. Now we are not talking about the volume. Later on I will give you examples with volume, but first you have to learn what is the proportion. So we have a beaker of 95% alcohol, and another beaker we have the 50% of ethanol. And the question is how we can mix these two proportions, these two alcohols, to get alcohol 70%. So in this case, we have to use alligation alternate to solve the questions. For alligation, we have to write a table. In this table, it has 9 windows. A very beautiful window, a table. It should always be this way. On the left side, you should read the question and you should put the highest concentration of alcohol that you can see. So highest percentage of alcohol. In this example is alcohol. Another example, it could be powders, it could be ointment. The important thing is you should put the highest percentage of what you have here on the left side. Lower side, you have to put the lowest percentage of alcohol. In this question is alcohol. Okay? And in the middle, you should write your desired percentage that you are looking for. Desired value that you are looking for. Okay. So, how can I translate this to our questions? How can I use our question, the data in our question to solve the problems? Again, you should put the beautiful window. You put the highest percentage of alcohol here. What is the highest percentage? In what proportion should alcohols 95% and 50% to be mixed to give 70%? The highest here is 95%, highest. You put 95 here. Then you should put the lowest percentage of alcohol. What is the lowest percentage? 50 or 70? So it's 50. Lowest. You put 50% here. So the value that you're looking for is 70%. So your desired value, which is percentage of alcohol here, you should put in the middle window. Okay, this is the first step. The second step, you have to subtract them from each other. But how? This way. 95%, you have to subtract it from 70. The answer would be 25. 25. And now you have to subtract this 50 from 70 or 70 from 50. The answer is always positive. You have subtract them from each other is 20. Now you have the answer. You have to mix 20 parts of alcohol 95% with 25 parts of alcohol 50% in order to get a proportion of 70%. That's easy. So this value, the proportion, the ratio would be 20:25. This is the ratio. So it's an expression of two quantities. 20 is written and read like 20:25. But as I said, there is a fact. If you watch my video number 1 about ratio and proportion, you will understand it. This is the same as common fraction, but the way that we present it is different as common fraction. So it is like 20:25. There is a expression of equivalent ratio, means if we divide each term, each side to the same number, the value would be the same. So let's say we divide them by 5. So it could be converted to 4:5. Means instead of 20 parts, we can write 4 parts. Here, instead of 25, we can write 5 parts. So 4 glasses of alcohol, 95%, or 4 beakers, should be mixed with 5 beakers of 50% ethanol to give question mark beakers, 9 beakers of 70% ethanol. So this is the answer. But you may ask how we can prove it mathematically, that what I'm telling you is correct. I will clean the board and I will give you the answer. So I will let it here, I will let it be. I just remove this part. So I should do it a little bit smaller. Let's say we put this window, beautiful window. The highest amount of alcohol that we have, we name it A. And the lowest amount of alcohol that we have, percentage strength of alcohol that we have, we put it B. And our desired percentage strength of the alcohol that we're looking for, we put it here as C. The proportion of the first alcohol, we put it as X, and the proportion of the second alcohol, we put it at Y. And now, we use this table and provide a ratio of X to Y. So, there's a ratio of X to Y. That's a basic mathematics. So, AX plus BY equal to C multiplied by X plus Y. Okay? If you want to write it down, we write it AX. You can write it like this. BY is equal to C multiplied by X plus C multiplied by Y. So, what we can do now, we can put X on one side and we can put Y on the other side. So, you put AX minus CX is equal to CY minus BY. Okay. Now, we can do like, we can remove this X. Here we can remove Y. We can say X is A minus C and Y multiplied by C minus multiplied by, I'm sorry, that's correct. It's C minus it's A minus C is I'm sorry, C minus B. So again, X, remove it, A minus C is equal to Y, C minus B. Now, we do like x over y is also equal to c minus b over a minus c. So, it means x is equal c minus b, as I mentioned it a few minutes ago, and y is equal a minus c. So, let's say we use this value, we use this formulation, and we put our values in our questions back to this formulation. What is A? Alcohol with a higher concentration. What was it? 95%. So we put 95x plus. What was B? B was our lowest alcohol concentration. So what was that? That was 50. 50y. What was C? Our desired strength. 70 multiplied by x plus y. So you can follow all of them to reach to this value. This value is x plus y is equal to, if you continue this, it's 70 minus 50, 97 minus 70, the answer is 20, 25. We simplify it to 4 parts to 5 parts. Did you understand it? So I use this calculation. I use A, the highest alcohol, 95%. I use B, the lowest alcohol concentration, 50, and instead of C, which is our desired alcohol, 70. And as I follow this step, I got to this step, and I also simply replace them. You got the same answer. The ratio of 4 parts of alcohol, 95%, should be mixed with 5 parts of the alcohol, 50%, to get us to alcohol 70%. So this is so this method, actually you do not need to know it, because by knowing this alligation alternate and using these tables, you can solve almost every question in this area. So I try to give you some more questions and we solve it together, and I hope you can learn it properly. So I again try to clean the window, clean the board. So it's readable, so no worry. So there you go. The second question would be in what proportion, the question is, I try to use a little bit happy colors, in what percentage should 20% benzocaine, it's a local anesthetic, benzocaine, should be mixed with an ointment base, should be mixed with an ointment base to produce 2.5% benzocaine. So that's a very good question. It's simple, it's also a very good question. Let's say you're a pharmacist, you're working, you have a benzocaine 20% in one hand, the tube, and you have some ointment base, or possibly you have some Sebexol, or you have some similar fatty base, and you want to mix them together in order to get 2.5% benzocaine. It means how many grams of this ointment base should be added to 20%, in what proportion to get to this one. Again, you can use a table, the beautiful table, this beautiful window. What is the highest concentration that you can see it here? 20 or 2.5? So 20. So I have to write it here. What is the lowest concentration that you can see? Should be mixed with an ointment base to produce 2.5. Is it this one? No. Ointment base. How many active ingredients in ointment base? So you have ointment base. It's a base. It contains no active ingredients. So it's 0. So the lowest concentration is 0. The highest is 20. What we're looking for? 2.5. So now what we do? Second step. Subtract them. 0 minus 2.5, 2.5. 20 minus 2.5 is 17.5. So 2.5 parts of 20% benzocaine should be mixed with 17.5% or parts or gram of ointment base to give us 2.5% benzocaine. Okay, let's go to the second question. So I try to bring a clean paper, just a second. So here we go. I clean the board using again, don't worry about the dirty board. As long as you can read it and you can learn it, that would be enough. So the second question would be using alligation alternates. There's a hospital pharmacist, a beautiful hospital pharmacist, using 3 zinc ointments. So he used 3 zinc ointments. He goes to the hospital, he goes to the lab, he used, in one hand he has 50% zinc oxide, in other hand he has 20% zinc oxide, and he also has 5% zinc oxide on the table. So he wants to mix these 3 zinc oxide ointments to get to 10% ointments. Then the question is, in what proportion? What proportion? So till now we had 2 different concentrations, 2 different mixtures. So we had alcohol 95%, we had in other hand 70%, and we wanted to mix in a way to get, for example, to the desired 50% strength percent. Here the pharmacist has 3 preparation. Good. Again, the same beautiful table, you have to draw it. So what is the highest concentration? Write it here. 50. What is the lowest concentration? 5. So, and here there's also 20. So in this case, you can write another table. For example, you use another table for 20 and 5. So it's say 20 and 5. So you calculate it 1 times with this, so it's say 10%, or and another one with another table. So and at the end you have to sum everything up. Let's say Again, the highest concentration in one table is 50, the lowest is 5, the other one, the lowest remains 5, and the second highest is 220. And our desired concentration, what this beautiful pharmacist is looking for, is 10%. So 50 minus 10 is 40, 5 minus 10 is 5. 5 parts, 40 parts. 20 minus 10 is 10 parts, and 5 minus 10 is 5 parts. Now, at the end you have to sum it up. How many parts of 50% is required? How many parts do we have here? We have here 5 parts. 5 parts. How many parts of 5% is required? In this table we have 40 parts here, 10 parts here, sum it up, together 50 parts. 50 parts of 5%. I'm sorry for the handwriting. And 20%, how many parts you need? 5 parts. So you need altogether 5 parts of 50%. You have to mix it with 50 parts of 5%, with 5 parts of 20% to get question mark parts of 10%. Okay? So this is the second question. I think this is the third question. Let's go to another example. We use, instead of 3 different concentration, we use 4 different concentration. So, as I said, in this question, I use 2 tables, but if you do not mix things, you can also use 1 table. Means, instead of putting 20 here, you can put 20 here, and do it here. 50 minus 10 is 40, 20 minus 10 is 10, 5 minus 10 is 5, 20 minus 10 is I'm sorry, 20 minus 10 is 5. So that's it. So let's go to the second questions. Yes, correct. So I try to figure out which question is good for you. So, another question, I think it was a third question or fourth question, doesn't matter. As long as you can solve it, it's okay. So, oh good. In what proportions, question, in what proportions should the pharmacies, manufacturing pharmacies, mix? Here's a beautiful pharmacies. These manufacturing pharmacies should mix 20%, 15%, 5%, and 3% zinc oxide ointments to get to 10% ointments. So there is a manufacturing pharmacist. She has 4 different concentration of ointment in her hands: 20%, 15%, 5%, and 30%, and 3%. I'm sorry, 3%. And she wants to mix them together to get 10%. Again, if you mix different concentration and we need to reach to our desired concentration, we have to use alligation alternate method. Again, use this table. Here I want to use all this information in one table. So the highest value, 20, lowest value is 3. Now, in your mind, if you want to use one table, you do not have to use these two numbers. Again, the highest number here is 15, and the lowest number would be 5. So you can either put two different tables. In one table, use these values, and in another table, you use these values. But here, since I want you to use your brain, you just have to mix a little bit things up till you learn. I use every information in just one table. So you have to learn how to omit the vision of these two numbers. Let's say we want 10% value. 20, first I do not see these two numbers. 20 minus 10 is 10. We can write it down, 10 parts of 3%. How to mix it. You don't see it? You don't have to put your hand, just don't see it. 3 minus 10 is 7. So it's 7 parts of 20%. Now you do not see this info, you just see this info. Highest value, lowest value, 10%. 15 minus 10, 5. So you need 5 parts of 5%. You don't see this value, 5 minus 10, 5. So you need 5 parts of 15%. So at the end, you have to mix 7 parts of 20% with 5 parts of 15%, with 5 parts of 5%, with 10 parts of 3% to get to the 10% ointment. Okay? How many parts? You can sum them up. How many parts? So, simple answer. Another question that I would like to provide you, it's a little bit difficult, it's a little bit different, not difficult. So first, again, I try to clean the board. Actually, this is the hardest part for me, to clean the board. So, pharmacist is gone. I'll be on holidays. So, I give you last questions, and I hope you will understand them. So, it's the question one. It said how many of 2.5% weight per weight hydrocortisone cream should be mixed with 360 grams of 0.25% weight per weight to make 1% hydrocortisone cream. So how many grams of 2.5% weight per volume hydrocortisone cream should be mixed with 2.5 grams or so to make the 1%? Again, this beautiful table, I call it Alligation beauty table. So what is the highest concentration? 2.5%. First, you do not see this 360 grams. You do, as I said to you, the step. Forget about 360. First, write down the highest concentration here. Lowest concentration, 0.25%. And what you're looking for is 1%. Again, Don't look at it at the moment. We just want to confuse you. 2.5 minus 1 is 1.5, which is 1.5 parts of 0.25%. And from this part is 0.75 parts of 2.5%. So you need 0.75 parts of 2.5% hydrocortisone cream to be mixed with 1.5 parts of 0.25% hydrocortisone to give you 1%. But it's written mixed with 360 gram of 2.5. So here's 360 gram. 0.25% contain 360 gram means 1.5 part of 0.25% hydrocortisone cream contains 360 gram. So how much is in one part? 1.5 contains 360. How much is in one part? Proportion 1 multiplied by 360 divided by 1.5. So each part contains 240 gram. So each part 1.5 gram contains 360. We have 1.5 360 gram in one part 240 gram. So the question is, how many gram of 2.5% hydrocortisone should be mixed with? So we want to, how many gram is this? How many part is this? 0.75. What is the amount of the gram of ointment is one part? 2.40. How much is in 0.25? Multiply by 240. Multiply by 0.75. The answer is 180 gram. So 180 gram of 2.5% hydrocortisone cream should be mixed with these parts 360 gram of 2.25 to give us 0.25%, to give us 1% hydrocortisone. Okay? So I think that's it. I hope you enjoyed our lecture for today. Be safe and have a great time. Till next time. Bye bye.